Welcome, class. Today we're going to do something really interesting. We're going to take a concept that you probably last saw in an algebra class and transform it into one of the most powerful profit-generating tools in the entire business world. You see, we're going to build a bridge between the elegance of a mathematical curve and the hard, cold reality of a company's bottom line. By the end of our session today, you'll see exactly how a simple equation can be the difference between a business that's just struggling to get by and one that becomes a true market leader.
All right, let's just dive right into the heart of the matter. This question right here. This is the one that keeps CEOs, product managers, and small business owners up at night. Seriously. It doesn't matter if you're pricing a cup of coffee or a brand new software suite. The fundamental question is always the same. What is that one single price that will make us the most money? You know, if you price it just $1 too low, you could be leaving thousands, maybe even millions on the table. But if you price it $1 too high, well, your customers might just walk away to your competitor. This isn't just some academic thought experiment. This is a high-stakes balancing act where fortunes are literally made or lost.
So the formal term for finding this perfect balance, this sweet spot, is optimization. I really want you to burn that word into your memory because it is a core discipline in modern business administration. Optimization, it's the entire process of moving beyond simple intuition, beyond what just feels right, and moving toward finding the single best, mathematically provable outcome given a very specific set of circumstances and constraints. In short, it's about making decisions with absolute precision. Now, for centuries, business was really more of an art form. You can imagine an experienced merchant on the Silk Road who just had a feel for the right price for their spices based on years and years of experience. But in today's incredibly complex, data-saturated global market, well, that's just not enough anymore. On the left, you've got the intuitive mind. It's this tangle of experience, biases, and gut feelings, and it can be powerful, for sure, but it's also really unpredictable. On the right, you have the data-driven mind, and I want you to notice something important. Intuition isn't gone, it's just structured. The data-driven approach, which is really the cornerstone of your entire business education, doesn't replace business acumen, it empowers it. It allows us to build a model, test variables, and arrive at a solution that is demonstrably, provably superior. This shift is what separates modern giants like Amazon and Google from the businesses of the past.
So, in business mathematics, we don't deal with vague goals like, let's do better. We give these goals precise, measurable targets. Now, I want you to remember the fundamental equation from your accounting classes. Profit equals revenue minus cost. Each one of these can be an optimization target. A logistics company, for example, might be laser-focused on minimizing costs, things like fuel, warehouse space, labor. A brand new tech startup, on the other hand, might focus on maximizing revenue to gain market share, even if it's not profitable just yet. But most of the time, the ultimate goal, the holy grail, is to maximize profit itself. And that requires a really sophisticated balancing act. So today, we're focusing on that ultimate goal, finding the absolute peak of the profit mountain.
Now, to solve this problem, we're going to use a tool that might just surprise you. It's a shape you've known since you were a teenager, but today we're going to view it through a powerful new lens. I'm talking about the parabola. That's the curve created by a quadratic function. It might seem simple, but this elegant curve beautifully models the complex interplay of price, demand, and profit in the real world.
Okay, let's really break this down. You don't need to be a pure mathematician to be a successful business leader, but you absolutely must understand what the different components of this model represent. In our profit function, y equals ax squared plus bx plus c, y is the variable we want to maximize, our profit. X is the variable we can actually control, our price. Now the other letters, a, b, and c, these are parameters that are determined by our business reality. C, for example, often represents our fixed costs, the rent, the salaries we have to pay no matter what. B is usually influenced by our variable costs, but the most important parameter for the shape is A. In profit models, A will almost always be a negative number. Now, why is that? It's because a negative A value is what gives us a parabola that opens downward, which means it has a distinct peak, a maximum point. These aren't just abstract letters. They're placeholders for the hard financial data of your company.
Now, what's truly elegant about this model is why it's a parabola. Let's just think it through logically for a second. If you set your price at 0, you're literally giving your product away. You might have tons of happy customers, sure, but your revenue is 0, and with your costs, your profit is actually negative. That's the first point where the curve crosses the horizontal axis. Then, as you start to increase the price from 0, you start making money, and your profit curve begins to rise. But if you keep increasing the price indefinitely, you're going to reach a point of diminishing returns. At some crazy high price, very few customers are going to buy your product, your revenue plummets, and your profit will fall, eventually dropping all the way back to 0. That journey, from zero profit up to a peak and then back down again, is perfectly described by a downward opening parabola.
Let's make this really concrete. Imagine we are a new software company. We're going to follow the curve on this slide. Scenario 1, the price is too low. We price our new application at just $5. We're the cheapest on the market. We sell 10,000 copies, which sounds fantastic, right? But our costs average out to $4 per copy. So our profit margin is just $1. 10,000 units times $1 profit, that's a total profit of only $10,000. We're working really hard, but not very smart. Scenario 2, the price is too high. Okay, now let's jump to the far right side of the curve. We get greedy. We decide to price it at $500. Our profit margin is huge, maybe $490 per sale. But the market for a $500 app is tiny. We only sell 25 copies. So our total profit is now $12,250. It's a little better, but we are missing a massive opportunity. Scenario 3, the optimal price. Now, our mathematical model, the vertex of our parabola, tells us the optimal price is actually $80. At that price, our sales volume is a solid 2,000 copies. Our profit margin is $76 per copy. Now, multiply that out. 2,000 copies times $76 profit per copy gives us a total profit of $152,000. That is the power of this analysis. It's not about guessing, it's about calculating the peak.
So this right here is the critical takeaway. That peak of the curve, the point we call the vertex, is not just some abstract geometric concept. In a business context, its coordinates give you two incredibly valuable pieces of information. The x-coordinate tells you the optimal price you should charge to achieve maximum profit, and the y-coordinate tells you exactly what that maximum profit will be. Finding this vertex isn't just solving a math problem in a textbook, it's finding the answer to a million-dollar question that can give a business a massive, data-driven competitive advantage.
Now, a word of caution. As future business leaders, it is absolutely vital that you understand that these models are powerful, but they are not crystal balls. The most common and dangerous mistake is to treat the model as absolute reality. It's always a simplification of a much more complex world. There's a phrase in data science, garbage in, garbage out. Just imagine your market research only surveyed college students for a product that's aimed at senior citizens. Your data on price sensitivity would be completely skewed, leading your model to suggest a price point that alienates your actual target demographic. That's a multi-million-dollar mistake that started from a single flawed data set. What's more, the model is static. If a new competitor enters the market tomorrow with a better product, your entire profit curve can shift dramatically. Never forget that these are tools to aid your strategic judgment, not replace it.
So, we've firmly established the power of the quadratic function in optimizing a single variable. But a modern business is rarely that simple, is it? This leads us right into our next section, where we're going to place this tool into a much larger context. Let's take a look at the complete business math toolkit that modern professionals are really expected to master.
You see, a sophisticated analyst never relies on just a single tool. I want you to think of it like a mechanic's toolbox. We've just learned how to use a very powerful wrench, the quadratic function, and it's perfect for optimizing a single variable like price. But what if your profit curve isn't a perfect symmetrical parabola? For something like that, you need a more advanced tool, derivatives from calculus. A derivative can tell you the slope at any point on any curve, and at the absolute peak of that curve, the slope is exactly zero. It's flat for just an instant. Calculus allows us to pinpoint that exact location. And what if you need to optimize an entire factory's production schedule with dozens of products, all competing for the same machines and raw materials? For that, you'll use matrices to organize all that data and solve for all those variables at once, finding the single most profitable combination.
And this, right here, brilliantly illustrates the fundamental why, the reason you are sitting in this course. It's not about learning to solve abstract equations just for their own sake. It is about learning a new language, a language that allows you to take messy, complex, real-world operational challenges in pricing, in logistics, in investment strategy, and translate them into a structured, solvable mathematical framework. And this framework doesn't just give you an answer, it gives you the best possible answer, the optimal path forward.
So, where does all of this lead? Well, understanding the parabola is the essential foundation. It's the first step on a much larger journey. From here, we can begin to look beyond the curve and start tackling the even more complex, multivariable optimization challenges that really define modern business.
As we prepare for our next topic, I want you to start thinking on a grander scale. Today, we focused on solving for one product's price. But what about a company like Procter & Gamble? They have hundreds of products, and many of them share production resources and even compete with each other for shelf space. How do you possibly price and produce them all to maximize the total profit of the entire corporation? Well, that requires moving beyond a simple two-dimensional curve into multidimensional space, which is exactly where matrix theory and linear programming come into play.
This is the future of data-driven decision-making, and it's what companies like Amazon, FedEx, and Walmart have literally built their empires on. We move from just finding the peak of a single hill to navigating an entire mountain range of variables. We use these advanced techniques to answer incredibly complex, high-stakes questions. Questions like this. Given our 5 warehouses, 300 trucks, and 10,000 daily deliveries, what is the absolute most fuel-efficient, time-efficient routing plan for our entire fleet, taking into account traffic patterns, delivery windows, and truck capacity? That is a multi-million-dollar optimization problem, and the companies that can solve it win.
So, to conclude, the key takeaway is this. Mathematics provides a universal language that we can use to describe the world, find its hidden patterns, and optimize for the best possible outcomes. The parabolic shape of profit is just one of those patterns. As you move forward in your studies and then into your careers, I want to challenge you to look for these underlying structures in everything you do. This way of thinking, this ability to model a problem, identify the variables, and solve for its optimal state is one of the most valuable and transferable skills you will ever develop for success. Not just in business, but in any complex environment you find yourself in.